1 and 2, they want us to expand the expression. Okay, so we should know that an exponent means that I am multiplying whatever it is by itself that many times, however many times the exponent is. So this one says t to the third. That means t times itself 3 times. So I would have t times t times t. Right? Okay. Times, because there's another times right here, t to the fourth. T to the fourth means t times itself 4 times. So 1, 2, 3, 4. So how many do I have altogether here? So 7. So this would be t to the 7th. Because when there is no exponent written, we know the exponent is just 1, right? So all of these really are just 1, so I just added them all up. Right? Okay, number 2, same idea. Here it says that I am just raising the letter to that power, right? It does not say the number is being squared, just the letter. So I have this 5, but then I also have times s times s. It said s 2 times. Okay. Times my next number, which is 6, times how many s's do I have this time? 6. So 1, 2, 3, 4, 5, 6. Okay. Now, we did have a rule for our variable over here, but I actually can multiply the numbers together, right? So what does 5 times 6 give me? 30. Okay. So I have 30, and then all of these are the same letter. And how many did we have? 8. So I will have 30s to the 8th power. Yes, I remember. Awesome. Uh-huh. So this says that the exponent's only with the letter. If it was like this, then the square would be with the number 2, but it didn't have the parentheses. So we know it's just with the letter that's beside. Yes.
Like in 8th grade, I was just kind of taught that like the coefficient.
Okay. So basically we have said here what we're doing is counting up how many letters we have, or adding all the letters together, right? That's the rule that they're explaining to us here. It says to multiply powers with the same base, all we have to do is add the exponents. So it says for every non-zero number b, so b just stands for base, right? That could be anything. If I have b to some power times b to some other power, all I have to do is add those 2 powers together. M plus n. Okay? All right, so on this first one, we're going to use that rule, but we're also going to check it the old way to prove if it works. Okay? So first of all, 2 to the 3rd power would mean 2 times itself 3 times, right? So 2 times 2 times 2 times 2 to the 5th power would be 2 times itself 5 times. 1, 2, 3, 4, 5. So all together, how many 2's did we have? 8. 1, 2, 3, 4, 5, 6, 7. So this way we got 8. Let's see if we had used their rule. Their rule was just to add the exponents, right? So in our case, that would be 3 plus 5. And what is 3 plus 5?
8.
So the rule works. So we are like saying, so we're going to multiply the coefficients, but all we have to do is add the exponents. Okay? So here, I would actually multiply the numbers. What is 2 times 3? Good. But then I'm just going to add the exponents within. So 5 plus 4. Good. And there's my answer.
What's the for
What?
So
We're about to do number 3. you said, number 3?
Yeah.
Okay, so let's look at number 3. Okay. Or sorry, on this one?
Yes.
What? What was your question?
Like, so you know how we multiply 2 and 6?
So, on number 5, we're going to multiply our numbers, right? So what's 14 times 2?
28.
Good. Okay, and then I add my exponents, but I only add the ones that have the same base, right? So for x, I've got a 2, and is there any x's over here?
No.
So I just have x squared. For y, I've got a 4 here and a 3 here. Altogether, that would be 7. So I have y to the 7. And there we go. So, do you see how y has an exponent of 4 right here? And how it has an exponent of 3 over here?
Can you slow up a little bit?
Guys, I'm recording this lesson, so try and not talk over each other. So, our rule up here, Scott, said that if we had that, the same base, all we have to do is add the exponents. So what we did was we added 4 plus 3, and it gave us the 7. Okay. Same idea here. We added 5 plus 4, and it gave us 9. Alright? Okay. On number 6, we multiply the numbers, right? So I've got 10 times 3, which would give me 30 times 2. Good. Okay, now I worry about my variables exponents. So we start with x. This x does not have an exponent written. Good. So we know it's 1. So it's 1. This one is a half. So right now I'm adding 1 plus a half. And then what's my last exponent for x? 2. So these are the things I'm adding up. Okay, so we have to keep it as a fraction for our final answer. So in your calculator, you could type 1 plus 1 half. So just put it in parentheses, plus 2. And it gives me a decimal, but to convert it back to a fraction, all we have to do is math, enter, enter. So we get 7 over 2. Okay. So I have x to the 7 over 2 power. Okay. Now I'm going to worry about the y. So for y, my first exponent is what? Okay, so I've got 9 over 2. There's no y's in the second term. But in the last one,
7 over 2.
It is full.
okay, you could do this in your calculator, but it's a common denominator, so we could do this ourselves. What is 9 plus 7?
16.
So I have 16 over that common denominator of 2,
Would be 8.
which is just 8. 16 over 2 is 8. Okay.
If you could simplify, so if you can tell with the description.
So, on number 7, it says find the area in square units of a rectangle that has a width of 2x squared y squared and a length of 4x to the 5th y to the 1/3. Okay, so it asked about area. How do you find area of a rectangle? What's our formula?
Base times height.
Base times height or length times width. Good. Alright, so it tells me the width and it tells me the length. I just have to plug those into the formula, right? So my length, it says, is 4x to the 5th, y to the 1/3, times the width, which they said is 2x squared y squared. So it's really just asking us to do exactly what we did on the problems before. I multiply the numbers first. 4 and 2 is going to give us, good, Alright, then I'm going to deal with my x's. Here I've got a 5, and here I've got a 2. So I have x to the, good. And then here I've got 1/3 and 2. So I could type that in my calculator. 1/3 plus 2 gives me this decimal. And then I convert it back to a fraction. Math, enter, enter. We end up with 7/3. So, here we are, and this is our area. Right? Okay, let's flip it over on the back. Yeah. Okay. Okay, so here on the back, again, it's asking us to expand and then reduce or simplify. Okay, so in the top, if I have b to the 5th, that means b times itself. Guys, put up your phones, please. How many times? 5. Good time. So I've got 5 b's here. Yeah. Okay, over how many in the bottom? Okay. And if I have something over something, they take each other out, right? So like these two would go away. These two would go away. And how many am I left with? 3, and they're all in the top, right? Mm-hmm. So my final answer would be b to the 3rd. It is over 1, but do we have to put the over 1? No. So we're just going to leave it as b to the 3rd. Okay? All right. Same idea over here. It just basically flips then, right? So this time I have 2 in the top, but 5 in the bottom. And they still will divide out, right? So these will go away, and these will go away. And I'm still left with 3, but they are in the bottom. Yeah. We do leave that 1 in the top, right? Because b divided by b is still 1, right? There's still a 1 up there.
Would it be d over 3 or b?
1 over b cubed. Okay? Okay, so then they give us the shortcut rule for what we are actually doing here. They say that if you are dividing powers, which is what we're doing here, right? Dividing, and they have the same base, so the same bottom part, then you can subtract the exponents. Well, if we look up here, that's basically what we did, right? 5 minus 2 gave us 3. 2 minus 5 would give us -3, so we left it in the bottom. Okay, so they give us an example of that here. We have this common base of 3, right? So I can subtract the exponents. What is 4 minus 3? 1. So I have 3 to the 1st, but do I really have to put that 1 there? It's an understood, so I can just have an answer of 3. All right, same idea here. I can subtract. What is 3 minus 10? 7. But the bigger number was in the bottom, so I'm going to leave it in the bottom. 1 over a to the 7. So wherever your bigger number is, that's where you leave it. Okay. Right here. 4 minus 3 gave us 1. Is 4 or 3 bigger? Is 4 or 3 bigger? 4. So we left it up in the top. Here, 3 minus 10 gave us 7, but is 3 or 10 bigger? 10, so we left it in the bottom where the bigger number was. We're just subtracting, but leave it wherever the bigger one was. Okay, number 10, I'm going to subtract. So for my x's, I have 3 minus 2, which leaves me with 1. And should I put it in the top or the bottom? Top. So I have x to the 1st in the top. All right, and then I've got 5 minus 2 for my y's. 3. 3, and then does it go in top or bottom? Do I really have to put that 1? So I would just have x, y cubed. Okay? Alright, number 11. We actually divide the numbers just like we actually multiply the numbers. So start with that. 8 divided by 2. 4. Good. And then I subtract exponents. So I've got 5 minus 8.
Yeah.
It's going to give us negative 3, right? But which one was bigger, the top or the bottom? Bottom. So I'm going to put m to the 3rd in the bottom. Okay. All right. And then I have 7 minus 4 over here. That's 3, and the bigger one was where? So that's where I'm going to leave it. And then we're done. Well, if you want, we could write it out every single time.
Wait, why didn't you multiply the numbers on number 3? And just do the exponents.
On numbers
Yes,
here?
front, right here.
Here. Which
On the front.
oh, because we're not actually trying to get rid of the base.
Oh, okay.
We were just simplifying the exponent.
Okay.
Okay. On number 12. We have some stuff multiplied in the top, so I'm going to do that first before I worry about the bottom. So ignore the bottom for right now. In the top, we have to multiply the numbers. So what is 6 times 3?
18.
Okay. And then when I multiply, I do what? We add. So 4 plus 2?
6.
A to the 6. Okay, and it is still over 2a to the 5 over 2. Okay, now I use the subtraction rule we just learned. Well, I actually divide the numbers. 8 divided by 2?
9.
Alright, and then I'm going to subtract 6 minus 5 over 2. Again, we don't want a decimal, so I'm going to do it in my calculator. 6 minus 5 over 2. So it's 7 over 2. And was the 6 or the 5 over 2 bigger?
Could you type
6.
5
Yeah, and convert it to a decimal so you know. Yeah, that would work. But it would be half of this, so it would be 2.5. So it's 6 and 2.5. The 6 is bigger, right? So I'm going to put it in the top. But yes, you can do that. So if you're not sure what that actually is. That's a great idea. Okay. Alright, and then last one like this. Again, we take care of the top first. So I multiply my numbers. Negative 3 times 4 is going to give me. Okay, and I'm adding exponents. It didn't put any here, so I know it's 1.
So that would be 4.
Right, 3 plus 1 is 4. Oops, what did I just say? Okay. Alright, and then for n, I would have n to the still over 6m squared n cubed. So now that we took care of the top, or we simplified the top, now we're going to divide. So negative 12 divided by 6.
Negative 2.
Okay. Alright, and then I subtract 4 minus 2.
2.
And is it top or bottom?
Top.
Good. These two things are exactly the same, right? So here's my final answer. Okay. Alright, last one. It says that the area of a parallelogram is 36x to the 8th y to the 7th square feet. The height h is the parallelogram is 9x cubed y to the 5th. The area of the parallelogram can be used, or can be found using that formula. Find the length of the parallelogram's base. So we're looking for b, but they gave us a and they gave us h. So I'm going to plug in a. They said a was this. So I have 36 x to the 8th, y to the 7th. following this formula, I would put equals b times h. And I said h was the 9x cubed y to the 5th. Alright, now I'm trying to get b by itself. Right now it's being multiplied, so how would I get rid of it? Divide. So I'm going to divide by 9x cubed y to the 5th. And if I do it on one side of the equal sign, I'm also going to do it over here. So that's going to make those go away. We haven't done any math yet. All I did was plug in what they gave me. So, I am dividing here. 36 divided by 9 is, then we subtract the exponents. 8 minus 3 and 7 minus 5. So there's my base.